Hello and welcome to video 2 in my Modelling in Maya series. So now we have a basic understanding of polygons and the different ways we can use them. We are ready to start looking at building our character. Here we have the two model sheets, or turnarounds as they're also known, and these will help to guide us as we create our succubus. There are two here because I thought we would first build a female base mesh. It's always good to have your own base meshes, as it can save you a lot of time when it comes to creating future characters and creatures. Now we have those to guide us, we can start to set up the scene, and that's what we will focus on in this video. I have a quick question. How would you like to help support the future of this channel and help to keep these videos free? Well, there are a few options. One would be to simply treat me to a coffee at my coffee page as a quick and easy way to say thank you. You could also download something from the antCGi store, or alternatively one of my other online stores like QBrush and Gumroad. However, for as little as 99p a month, you could join the antCGi club. There are a few ways you can join. You could head over to my Patreon or Coffee pages, or alternatively simply hit that join button below this video. In short, the more support I get, the more time I can dedicate to creating more high quality content just for you. To get more information on how you can help, follow the link on the screen or in the description below. Okay, that's enough about that. Let's get on with the actual video. Okay, so there are a number of things you should do before you start any new project in Maya. First, it's a good idea to actually create a project. And what this will do is keep everything localized in your directory structure, so it's easier for you and Maya to find things. Plus, it keeps everything neat and tidy. So to do this, we go to File, Set Project. You then need to specify a location for this project. So for me, I want everything to be inside this folder. Now I click Set. We will now get a warning. But all this means is this location hasn't previously been defined for a project, so it hasn't found one. So now create a default workspace. If we look in the folder now, you can see we have a new file, and that's the workspace.mel file. This just sits here to tell Maya that this is being used as a project location. If we look at that file, we can see a list of folders, and these are file rules for the project. They basically tell Maya where to put things when you decide to save or export. So we can see here that Maya ASCII files and binary files are automatically put into the scenes folder. The problem is we currently don't have these folders available, but we can quickly add them if we like. This time go to File, Project Window. So with this tool we can see the current project and its location. We can also see a list of primary locations below. We also have secondary locations, translator data locations, and you can also create custom data locations too. Let's close these. If I click Accept now and go back to the folder, you see we have lots of lovely folders now. And Maya will use these to organise the scene files for you. Source images already existed, so Maya didn't recreate it. And you can see my files are in here too, so it also didn't remove my folder and replace it. These are the divided model sheets we will be using in this course. So now the project has been set, we can start to configure the scene. The overall scale of the scene is important, especially when doing something like rigging. With models, it's very easy to quickly adjust the size of them, but it makes sense to start as you mean to go on. The first thing to do is check what units you are working in. Go to Windows, Settings, Preferences, Preferences. Here we can see all sorts of options, allowing you to configure Maya however you prefer to work. For now, go to Settings. What we need to check are the working units. We can see it's currently set to centimetres, which means all the units and values we see and adjust are in centimetre values. We can change this to various other units if we need to work to a particular scale. One thing to keep in mind is that Maya uses centimetres internally to run calculations on dynamics and rendering. Now I realise we're just modelling, so it's probably not an issue for us, but it's worth considering if you intend on rendering this model later, or doing something like adding subsurface scattering to the skin, or even if you're planning on using Nhair. It's also worth talking to the team you're working with and seeing what units they are working in, to keep things consistent. For now, let's work in centimetres. Let's switch to the 4-panel view so we can see the different angles as we adjust the grid. Looking at it, the grid looks fine, but it's always worth going in and double checking just to make sure it's set up exactly as you want. So let's take a look. Go to Display, Grid and open the options. Let's adjust this and focus on the size section. As you can see, the length and width is set to 12, and this is the overall size of one section of the grid in squares. So a section like this, not the entire grid. And this means the grid is only showing a line at every 5th centimetre. Finally, we have subdivisions, which is also set to 5. So basically, each grid section is 12 units wide and deep, and then this is divided by 5 to give us the grid lines, and then those again are being subdivided by 5 again. It can sound a little confusing, so let's simplify things and set all these to 1. And apply that. So now we are looking at a grid which is simply 1 centimetre, but we have 4 because the grid extends out from the world root. Now we know we are looking at a single centimetre, we can adjust this to get a grid we can use. When building characters, I prefer to have a cleaner grid, which is set to 1 metre. So let's make this grid a metre wide by setting this to 100 units, which is equivalent to 100 centimetres. And apply that. So now we have 4 metres, but it's too cluttered, so let's simplify it. Now set grid lines to 102. So we only get a line at every metre. That's much better, and we know each of these is a metre square. Now we have that, we could add a subdivision, just to break it up a little, like this. Or maybe 3. Okay, let's leave it at 2. If you wanted, you could also change the grid colours. So we could change the main axis to red and make it clearer where the central axes are. Let's make it darker instead. Okay, so that's the grid ready to be used. I'm going to switch back to the perspective view now, and I can do this quickly by tapping space as I hover over the panel. The basic scene elements are set up now, so let's bring in the model sheets so we can work with them in the scene. We add these into the scene so that we can work directly on top of them, meaning our model will be more precise. Tap space to switch back to the 4-panel view. And in the front view, go to its view menu, down to image plane, and then over to import image. You see, because we set up the Maya project, Maya automatically knows we are looking for an image, so has taken us to the source images folder. And here we have the model sheets. You can also see I included a JPEG and a PNG version of each, and you will see why shortly. Let's use the front JPEG version first. So that's been brought into the scene, but it's far too small. I'll just press minus a few times to reduce the size of the manipulator. Before we scale it, let's also bring in the side model sheet too. So the same as before. Go to View, Image Plane, Import Image, and this time select the side view. So those are both in now, and they are the same size. So we can scale them both now to keep them in proportion with each other. Remember that each of these grid squares is half a metre, although when recording this I forgot that and thought that they were actually a metre each. So I will update the sizes before the next video. All we need to do is scale the image planes so they are at the correct size. And what will happen is you will usually get her height from your client along with the model sheets. First scale her to 2 meters tall, which is quite tall. Now scale her back down to around 1.8 and move her down so her toes are on the floor. Let's switch back to the perspective view, and you can see that the image planes are intersecting, so let's move them apart. We can just move them like any other Maya object. We are doing this so as we build the model, we can stay between them and they won't intersect with the model or get in our way. Okay, something like that will do. Now you could happily work like this, but you could also use the PNG versions of the model sheets instead. To swap, all we need to do is select the image plane. Go to the attribute editor and select the PNG version. As you can see, it's now transparent, so we can see through the plane, but the line art is still visible. Let's update the side view too. So that's another option for you, and it can make the image planes less intrusive. As a final step, I also like to lock these down. It's too easy to select them at the moment, and this can get annoying as you work. To do this, select an image plane, and in the attribute editor, make sure the shape node is selected. Now scroll down to the Drawing Overrides tab and enable the overrides. You can use this section on most of Maya's nodes to adjust how things are viewed, their wireframe colours, and how people can interact with them. All we need to do is change display type to reference. This will lock the image plane, meaning it can't be selected, but it's still there for you to refer to. Let's update the side view too. So you see, we can't select these now. If needed, you can still select them in the outliner. Okay, so that's the image plane set up. So next, let's look at adding some basic lighting to the scene, and let's also add a nicer shader too. These steps are optional, so feel free to ignore them. But when working with a client, I find it's better to include some lighting and a nicer shader for when you are sending screenshots and updates. It makes you look more professional, but it's not just that. It can also help you visualize how the surface of the model is being formed. So it is quite important when it comes to modeling. To be honest, the standard Maya Lambert can be a little flat and lifeless. Okay, let's create a basic sphere first so we can see what we're working with. To create one, you could go to Create Polygon Sphere, or just use the Shelf button under the Modeling tab. This will give us a sphere using the default options, which is fine because this is only here to help us see how the lighting will affect the model. Let's make this bigger and move it up. So as you can see, the basic Lambert is fine, but a little boring. Plus, we have no real feeling of depth, but adding some lighting will help with this. The kind of lighting we're going to add is based on a traditional 3-point lighting setup. So with this setup, we have 3 lights in the scene. A key light, which is the main light, and this is also the one that casts the main shadows. A fill light, which helps to brighten the darker areas of the model and acts like reflected light. And finally, a backlight, which helps to separate the model from the background, and it also makes it pop. We are going to use 2 of these lights, but do something a little bit different for the backlight. Okay, let's create the first key light. Go to Create, Lights, Directional Light. This will cast a light in a specific direction. So the arrows point in the direction the light is being cast. If we rotate it though, nothing is happening. And that's because the scene is being told to use the default light, which is being cast from the camera. We can change this in the lighting menu. Simply switch to Use All Lights. Now as we rotate the light, you can see it affecting the sphere. With a directional light, it's only its orientation that changes the lighting. Moving or translating it has no effect. Okay, let's rename this to key light. Let's also move this so it's roughly in the position it's being cast from too, just so we can visualise the lighting a little better. If we look at the sphere, we can see that the side which isn't being lit is very dark, and this is where the fill light helps, adding some fake reflected light to the scene and brightening this area for us. This time create a point light. And this emits light in all directions, so unlike the directional light, it works on its position, whereas its orientation has no effect. You could use another directional light as you prefer, and we will experiment with this later in the video. It just depends on the type of lighting you want and the overall look. Let's call this fill light and move it over to the opposite side. As you can see, it's already brightening that darker area, so we can adjust it to get a nicer fall off. But ideally, it should be opposite the key light. Okay, so those are the main lights. We will come back to the backlight later. So let's add some shadows now, and these are essential for grounding your model and helping to define the shapes and forms. First, let's add a floor to the scene, and we can simply create a polygon plane. So go to Create Polygon Primitives Plane and scale it up. So if we adjust the key light, we can see it shining on the floor plane, but because we don't have a shadow, we have no real feeling of depth and the sphere isn't grounded in any way. To see the shadows, all we need to do is go to Lighting, Shadows, and we can now see the sphere's shadow. What we can also see is that the fill light is also casting a shadow, but we don't really want it to. Let's disable it. So go to the Attribute Editor, and under the Shadows tab, we can see that the Ray Trace Shadows option is enabled. We also have the option to use depth map shadows, but we will look at those in a second. For now, uncheck this to turn off the shadow. And that's gone now. So the fill light is feeling more like the light being reflected from the floor now. Okay, let's adjust the main shadow. It's far too severe, so we need to soften it. First, we can adjust the colour. At the moment, it's just a black blob. Let's brighten it, and maybe add a slight blue tint to it. Okay, it's maybe a bit too dark still. Let's brighten it a bit more. Maybe a bit more. And reduce the saturation. Okay, that's looking better. If we take a closer look, you can see that the edge of the shadow is quite sharp. Now you might like it like this, and that's fine, but what if you wanted a softer appearance? Well, as we can see, this light is currently casting a ray trace shadow. These are a more precise way of creating shadows, as each light ray is calculated directly from the light. If we were rendering, we would probably use this option, and we could adjust the shadow rays and ray depth limit options to soften its appearance. For us though, we just want to make the viewport look a bit nicer, so these options won't work for us here. Another option would be to use a depth map shadow. You see, the shadow has changed and now looks more pixelated. This is because depth maps are represented by a file stored on the disk. The file size is indicated here, so we are currently using a small 512 by 512 pixel image, and that's why it's appearing pixelated. Depth map shadows are a lot quicker to calculate, so can speed up rendering times. What we could do first is adjust the filter size. If we ramp it up to its maximum of 5, the edges blur and soften the shadow. We can still see some of the pixel edges though, so in addition to this we could increase the resolution. Let's use 1000. So you see, that's helped, but it's also made the shadow a little crisper too. If we compare it to the ray traced shadows, you can see the depth map shadow is slightly softer. So it comes down to personal preference really. But remember that we are faking this, so the viewport model looks better, meaning we can quickly create screen grabs for our client, and it will help us as we start modelling. So again, this isn't really essential, so just pick the one you prefer. Okay, so we have our key light, and we have our fill light. So now let's look at adding the backlight. And for this, we're going to cheat a little. First, we need to update the basic Lambert shader. So select the sphere, right click and go down to Assign Favourite Material, Blin. This will create a new blend shader and assign it to the sphere for us. Straight away you can see this looks much better. We have a nice shine on the model now, which has helped to make it look more spherical. Let's update the colour first. So maybe something like this, more of a brown clay type colour. And we can adjust the ambient colour to brighten those darker areas and fake some subsurface scattering, which is the effect of light travelling beneath the model's surface. You usually see it used with skin or wax. Okay, now let's adjust the highlights. Again, we can change the overall colour. So let's add a slight blue tint to it to represent daylight. Desaturate it a little. Okay, eccentricity will adjust how wide the highlights are, so let's make it a little wider. And specular roll-off will control its overall brightness. So you see, we can disable it completely. Something like this will do. So we have an improved shader now, but still no backlight. What we're going to do is use some of Mayer's nodes to fake the effect of a light being behind the model. Click on the swatch next to the colour slider to open the node window. What we need is a ramp node. So you see, this has given us a basic ramp shader. And at the moment it's using the UVs on the sphere to project this ramp onto it as a texture. You can see a preview of the texture page up here. What we want to do is change this so the ramp instead uses the camera's position, so the middle of the sphere is one colour and then this fades out to another around the outside. Let's open the node editor. So go to Windows, Node Editor. This is the node editor and the ramp node is already in here because we had it selected. Now the node editor can be a little daunting, so if you're at all worried about using it or you want to know a little bit more about it, check out the video that's on the screen now. We can click the graph node button here to also bring in everything that the ramp node is connected to. So we can see the main blend shader here. Let's adjust some of these and rename the shader. Let's call it clay_matte, just so we know it's the clay material. And let's rename the ramp too. With the ramp selected, press 3 to open the node so we can see all the available attributes. Let's open the UV coord attributes. We need a new node now, so press Tab. This will bring up a small input box. Start to type surface and a list of matching nodes will appear underneath. Select the surface info node. This can be used to gather all sorts of data relevant to a model's surface. Now I'm not going to go into detail about all those now. Press 3 again to open it. And all we are interested in is the facing ratio attribute. This will help tell us which parts of the model are facing the camera. Click the small dot next to its name and drag down to V coord in the ramp node. You can now see that the shader on the sphere has changed, so we are getting a darker effect around the outer edges. As we move around the sphere, the darkness stays the same because it's always facing the camera. So we can use this to create our fake backlight effect, although this is probably more of a rim lighting effect. Let's go back to the shader and the ramp. So we can see the ramp currently goes from black to white, and that's what we are seeing on the sphere. We can now adjust this so we get a lighter rim. and change the black to be our original clay colour. So now we have the main shader, but also this nice rim around the outside. At the moment the gradient on the ramp is quite linear, but we can change that too. Let's swap the interpolation to smooth instead. That's better. We can adjust the light, and the rim stays locked onto the camera. Now we have those main elements in, we can start to play around with them to get the look we want. So with the fill light, we could change the colour, making it more yellow maybe, like sunlight. Feel free to just experiment with all the options until you're happy to move on. Okay, let's turn our attention to the floor plane now. At the moment it's quite harsh and quite solid, but using another ramp node we can soften it so we don't see the edges, and this will also help to fade the shadows too. So select the floor plane, let's move this up a little, right click on it and go down to assign favourite material again, but this time select Lambert, we don't want a shiny floor. So this time we are going to use the transparency attribute, so the edges fade away. So click on the swatch and connect another ramp shader. Now it's quite subtle because of the lighting in this scene, but what we have now is a gradual fade from one side to the other. If you don't see this in your scene, make sure you have hardware texturing enabled here. If I adjust the ramp, we can just make out the transparency changing with it. So in this instance, white represents the transparent pixels and black is solid, and the grayscale that moves between them is the blend. Now we don't want a linear fade like this, we want a more circular one, so it's more like a spotlight. To do this we can change the type from V-ramp to circular ramp. You can see in the swatch the texture has changed now, so the solid black area is in the middle now and it fades to white. Let's look at the shader to make it more obvious. Let's make the main colour more white. That's much better. We can start to see the fade towards the edges now. So let's pull the white in. Okay, great. We can no longer see the edges and instead we have a nice circular floor, which is great for doing screenshots. Let's also change the interpolation type to smooth to soften the gradient. Okay, it's maybe a little bit too solid in the middle. We can brighten the black in this to make it a little bit more transparent, or alternatively you could just change the main Lambert colour. So as you can see, the shadow fades away too, which is nice. Let's move the fill light. I'm going to change this to a directional light now, so you can see the difference. We don't need to recreate it, we can simply change the light type in the attribute editor. Okay, so that's completely different. If we make the light bigger, we can see it's pointing directly at the sphere, so let's rotate it. So you see, compared to the point light, we get less of a harsh highlight. Plus the directional light is easier to control and predict how it's going to affect the model. What we could also do if we wanted is disable the highlight altogether. All we need to do is disable Emit Specular here. We can also disable Emit Diffuse too, but then we lose the overall effect. Again, feel free to play around and experiment with all these options to get the exact look you want. Now there are a few more options you could use to improve the visual quality of the viewport. Go to Renderer, Viewport 2.0 and open the options. You will notice that the sphere looks quite rough around the edges, and so does the grid for that matter. We can soften those using anti-aliasing. If we enable multi-sampling anti-aliasing, you will see the edges become softer on both the sphere and the grid. We can also enable smooth wireframe too, which will do the same on the model's wireframes. We will see that more though as we work. We could also enable screen space ambient occlusion, which will add some ambient shadowing to the models. We can't really see that here though, so I will show it again later in the course. Both of these options do improve the quality of the viewport, but they can come with a performance cost, so it may be that these are something you enable before you take those screenshots. So that's the scene set up, and we are ready to start modelling. Before we end this video, I just wanted to quickly show you the shader on an older model of mine, so you can get an idea of the full effect with the rim lighting. If I adjust the ramp, you can see we can get more of a gradual effect. What we can also do is compress the ramp more, like this, and we get more of a cell shaded effect. So again, play around with these and see what you can come up with. Okay, that's the second video in the Modelling in Maya series done. In the next video, we will start to build our base mesh. Thanks for watching right to the end, and make sure you also check out some of the other free videos and courses that I have. You can find links to all these on the screen now and in the description below. Remember, to help support future content and keep these videos free, visit the antCGi store or join the antCGi club. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? Again, the link is on the screen now and in the description below. Thanks again for watching. This is antCGi signing off, and I will see you on the next one.